All right, let's get into it. We often think of soil as just, well, dirt, something that holds plants up. But right under our feet, there's this incredibly complex world, a hidden engine that's literally powering almost all life on land. And today, we're going to pop the hood and unlock the chemistry that makes that engine run.
I mean, this quote from the source material absolutely nails it. Soil isn't just inert stuff, it's Earth's living chemistry lab. It's this place of constant, buzzing transformation, where elements are being swapped and stored and released to keep everything alive.
And this lab is powered by what we're calling an invisible nutrient engine. Just imagine it constantly whirring away, driven by these amazing chemical reactions and microbial life, turning raw elements into the building blocks of, well, everything, from a single blade of grass to the food on your dinner plate.
So that's the big question, right? How does this engine actually work? What are the main controls? What's the fuel? And maybe most importantly, what happens when we really start to listen to what the soil is telling us?
Here's our game plan. First, we'll look at the two master controls that pretty much run the whole system. Then, we'll get into the fuel, these big, important nutrient cycles. After that, we'll meet some unsung heroes that make a huge difference. And finally, we'll connect it all back to the food we eat. So first up, the master regulators. If soil really is an engine, then you've got to have controls, right? Well, think of pH and something called Cation Exchange Capacity, or CEC, as the two main dials that control how well that engine performs. Let's start with pH. You probably remember this from high school chemistry, but believe me, in soil, it is the absolute master regulator. It basically dictates which nutrients are dissolved and ready for plant roots to drink up and which ones are totally locked away and out of reach. And you can see exactly what happens when things get out of whack. If the pH dips too low and the soil gets too acidic, like in parts of Assam, essential goodies like calcium become unavailable, and you can even get toxic elements released. But if it swings too far the other way into alkaline territory, like in Rajasthan, other crucial nutrients like iron and zinc get locked up tight. It's all about finding that sweet spot in the middle. Okay, the second master regulator is Cation Exchange Capacity, or CEC. And this is a really cool one. It's basically the soil's built-in ability to grab onto vital, positively charged nutrients. We're talking calcium, magnesium, potassium, and then supply them to plants right when they're needed. Honestly, the best way to think about CEC is like a rechargeable battery. The tiny clay particles and all the organic matter in soil have these little negative charges that act like magnets, holding onto those positive nutrients. So the higher the CEC, the bigger the soil's battery, and the more power it can store. And this is where something called base saturation comes in. Think of it like the charge level on that battery. You want it mostly full of the good stuff, these key nutrients like calcium and potassium, and not junked up with acidic ions. Soils with a high CEC, like the unbelievably fertile soils in the Ganges-Brahmaputra Delta, just have a massive battery, which is what makes them so productive.
Okay, so if pH and CEC are the master controls, what's the fuel for this engine? Well, that brings us to Section 2, the great nutrient cycles. We're talking about nitrogen, phosphorus, and potassium, the big three.
Nitrogen is the backbone of life, but it's a super tricky element. The whole cycle, which you see broken down here, is basically run by microbes. They pull it from the air, they process it from organic matter, and they turn it into nitrate, which is the form plants absolutely love. But there's a catch. If the conditions are wrong, that last step, denitrification, can release nitrous oxide, which is a really, really potent greenhouse gas.
Next up, we have phosphorus. And I love the way the source material describes it, the shy nutrient. It's absolutely essential for energy transfer in plants, but it has this really frustrating habit of, well, not wanting to play with others. It gets locked up. This is what's known as the Phosphorus Paradox. It's often right there in the soil, but it's unavailable, stuck to iron in acidic soils or calcium in alkaline ones. The real heroes here are these amazing mycorrhizal fungi that team up with plant roots. They release special compounds that basically pry that phosphorus free for the plant to use. Pretty cool, huh?
All right, now for our third key fuel, potassium. I want you to just look at this number for a second. 80%. Just hold that in your head. What do you think that could possibly refer to? It turns out that a whopping 80% of the potassium a plant uses can be put right back into the soil's bank account just by leaving the leftover stalks and leaves on the field after harvest. It's such a simple, powerful, nature-based solution. It's about recycling, not just constantly taking. Okay, so now we get to move on to the unsung heroes of our soil engine. These are the parts that might be small in quantity, but they have a massive, massive impact on the entire system. We're talking about micronutrients and soil organic matter.
This metaphor is just perfect. Micronutrients, things like zinc, iron, boron, they're needed in such tiny amounts, but without them, key processes just stop. They won't fire. They really are the spark plugs that ignite the whole engine of plant metabolism.
And this little table gives you a snapshot of why this is so important. Iron is absolutely critical for photosynthesis, but remember, it gets locked up in high pH soils. And then there's zinc. Zinc deficiency is a huge problem across South Asia, and it leads to this terrible thing called hidden hunger, where people have enough calories to feel full, but their food lacks the essential nutrients they need to be healthy.
And that brings us to the ultimate unsung hero, soil organic matter, or SOM. This is the good stuff. It's that dark, rich, beautiful blend of decomposed plants, microbes, and all that life. It is truly the cornerstone of all soil fertility.
I mean, SOM is the ultimate multitasker. Look at what it does. It's the food that powers the entire microbial world. It's the glue that binds soil particles together to create a healthy, stable structure. And it's the pantry that stores nutrients and then slowly releases them like a natural fertilizer. It's the foundation of a healthy soil engine, plain and simple.
So, in our final section, let's connect all this incredible chemistry back to our own lives. Because, understanding this invisible engine isn't just some academic thing. It's about how we can grow more nutritious food for everyone.
Let's look at a powerful real-world example. And again, let's start with a number, 15%. Now that might not sound like a mind-blowing number at first, but if you're a farmer trying to make a living, a gain like that can change absolutely everything.
And here's the story behind it. Rice farmers in Bangladesh were able to boost their yields by a full 15%. And how'd they do it? Not by just dumping on more of the big fertilizers. They did it by using simple soil tests to find and fix those hidden deficiencies of the spark plug micronutrients we were just talking about, zinc and boron. They just listened to what the soil needed, and it paid off, big time.
So we've pulled back the curtain on this amazing invisible engine. We've seen how its chemistry creates this direct line from the health of our soil to the health of our own bodies. And all of this really leaves us with one final crucial question. If the system is so important, what are we choosing to feed it?